awesome stuff on the internet, and it's like better explained when it's written, but I will more emphasize on the like social aspects of this like of this phenomenon actually that we are witnessing, like Bitcoin and Ethereum and the blockchains. And I believe this aspect is very much unappreciated. And the punchline is that even if you have really good tech, it's not enough. So the social aspect is actually the crucial thing. So the story begins with the famous story in the Bible about the Babel Tower, and if you recall, that was probably the first like international endeavor, like to build really huge thing, and like it required lots of coordinated effort, like people were building, and when the God decided that there is like enough is enough, just say, okay guys, now we speak different languages and you cannot coordinate with each other, and this is actually was the driving force. So the project was never finished, and as we know, right now we speak different languages, and we cannot really coordinate that efficiently as it used to be. So basically the moral here is that the ability to coordinate at the global scale when we have lots of parties enables genuinely new use cases and the possibility to do much greater things that we would be able to do individually. So let's then deconstruct like what is to do coordination and how actually the coordination, like what coordination mechanics we have right now, and look at the pre-blockchain era, how were people like doing global constructions and everything. So my point here is that any coordination mechanism always starts with a sort of meta-agreement, which basically says that we first define the rules, and according to these rules, we come to the consensus. So let me just give an example. So for example, in medieval times, the meta-agreement was that there is a king, is like the only person, and whatever the king says, everyone must be. And the meta-agreement was that this king is like this guy, and the fact, like, how do you become a king? Well, basically, the god appoints the king, and that was the meta-agreement. And here is like the thing, like what happens when you actually disagree on the meta-consensus. So for example, like you're like, I'm your king, like I didn't vote for you. Like I really don't vote for kings, okay? But then how do you so I'm a king because some lady on the lake like put me here, and the guy in Northland, the most important thing that like I think that supreme executive power derives from a mandate from the masses, not from some facial aquatic ceremony. We can't expect to wield supreme executive power just because some Valerie starts who is sword at you. So basically what happens here is that the peasant disagrees on the meta agreement, because the king says, okay, I'm a legitimate king because the lady appointed me. But since this guy says, no, this is not how actually the supreme power again, they have to vote for this, they cannot even agree with that. So right now we have sometimes democracy, and the meta agreement behind democracy is that we have an election, we have some certain rules of how we tally the votes, and whatever comes out is sort of taken for granted. So then we have this, for example, the president or like a chancellor, and he has lots of power, so basically we follow him. But we might disagree on the person, because someone voted for him, someone didn't, but we all agree on the meta mechanics that election is what makes people legitimate, right? So there are like different ideas, but basically everyone agrees that if people vote, whatever comes out is legitimate, even if we don't like it. So now comes the blockchain stuff, and the main breakthrough psychologically here is that right now, instead of like making a vote ourselves, we actually outsource the decision to the computers. And basically what happens is that we take a computer, we run a code there, and whatever the code is given to us is taken for granted. So by the fact that the code is open source, and we all see how this code works, and we all know that the computers don't lie, they just like follow the instructions, we outsource all the hard decisions, like who owns how much in terms of money, to this like soulless machines, and whatever comes out, we take for granted. And this is the Dmitrii agreement for like running a full node. The point is that in order to this work, we have to all like accept that whatever comes out from the full node, we accept as something that we take for granted as valid. And this is how actually Bitcoin accrues value, right? So, for example, we see that our full node, like running a Bitcoin code, and okay, right now I have this amount of Bitcoins, and then based on this information, we, for example, do some goods or transfer something to some other party. And this indicates that whoever runs the node except for me has pretty much the same belief and the same information that this Bitcoin has value. And also, we all agree that the miner rewards, mainly the Bitcoin printed out of thin air to the miner, is sort of a fair thing and legitimate, and we also, because this is written in code, and we all just don't complain about it, we just like taking it for granted, that's it. So, the point here is that there are two parts. The technical consensus is basically the technical thing saying that whoever runs the same code gets the same output from the code. This is actually a computer science problem. It is hard, but a harder part actually is a social, like sort of meta consensus, that the code actually means the same thing for whoever runs it. And this is something that we cannot actually code inside, but rather than we can build through adoption and like persuading people in some common belief. So what are the prerequisites to this social consensus? So in order to convince people to follow this creed, we need to have a bulletproof understanding that the technical consensus, the outcome of the technical consensus is very hard to gain, and that these outcomes are in some sense fair, that whatever this like soulless and stupid machines give us at the output actually aligns with our beliefs on how the goods are fairly distributed. Because if the, for some reason, like in the DAO hack, it happens that, okay, the code was just like following the instruction, but according to the output, some hacker like got all defense. Okay, the code never lies, it just like goes like this, the code is low. But we believe that this is just unfair, this is not like how we want this to be. And here we have a very difficult split between the social consensus and the technical consensus. And that's why, in order like to get the thing rolling, we need for the social consensus that the critical mass of people share the same belief. And this is sort of like a chicken and egg problem here, just because once you just start something, you already need a lot of people believing the same thing. And so that's why, for example, Bitcoin itself was struggling just to get adoption, and like Satoshi Nakamoto was just sending Bitcoins for free and like basically indoctrinizing people. And that's why I think having a very cool new tech with like binary hypercubes and super DEX, even if it's like 10,000 times faster and more efficient than Ethereum, is actually quite weak competitor to Ethereum, just because just too few people following it. And basically, the only hope is to put lots of creed from the Ethereum community to this new protocol and say that, okay guys, I have something like yours, but much better. And then just hope that they will just get out and like put and land on their protocol, which I think is a very difficult thing to do, but this is like my opinion of things. Like I believe that many people disagree, especially those who actually build these protocols. But my idea here is that the number of people who run full nodes is actually quite limited. And if I already run a full node and I put my belief in the output of this full node, I have to have very strong conviction to switch to some other node, because typically I cannot like have this large attention span in order like to handle like multiple instances of different beliefs within different protocols, so to speak. All right. So right now, like I wrap up the social consensus. I think this is like largely unexplored area, and we actually don't really know how this works. Probably the longer the protocol exists, the longer it will survive. But again, the number of data points is just too few. So that's why we move into the area where we actually know much better, and because we have like 20, 30 years of research, mainly the technical consensus. So technical consensus is something that's kind of easier to deal with because we are dealing with machines and the code which are not that complicated as people, and we can actually peek inside and like see what's going on. And so the setup is here, like as I said, that there are like lots of machines in the network, like called nodes, and some code is spinning in there, and they exchange messages through the network, and sometimes some nodes go offline, sometimes some nodes like join, sometimes the network can be slow, sometimes it's very fast, and also it may happen that like some people tweak with the code, and like sometimes they have just like some hacked version, sometimes they hack it themselves. So like also nasty things happen, but even in this like very adversarial environment, we can do lots of stuff actually. And I will go a bit more into technical details, like what exactly does this code do. So I'll write it here. Taking over our Telegram groups and everything. So basically, at the very general level, this code thing does very simple stuff. So we have some database, and you can update this database, you can read this database, and you can take updates from the network. So what happens is that when you want to make an update to your local database, you have sort of pending updates and something that are what is called finalized, something that are like set on stone. And the pending updates go into the final state. So basically you apply it to your database only if and when you're sure that everybody in the network will do the same, right? So, for example, you update your balances or UTXO ownership in the case of the BTC only when you're sure that pretty much everyone in the network have the same vision, like the same view of network. Otherwise, this transaction is confirmed, and you're actually not sure that everybody will do the same. So the hardest technical part is actually to decide when exactly, like this pending update goes to the final state, because it requires this knowledge about the whole network, so to speak. So, for example, it's you, here is your laptop, and here like the whole network. Basically, your decision is based on the information about the whole network. All other guys will do the same. And this is actually pretty hard to understand, but pretty hard to implement. The only assumption basically that you have is that all these guys are doing the same as you do. And they're, like in the very general situation, is more or less impossible to do just because you don't even have the whole view of the networks. And for example, assume that someone is doing the same on Mars, and you just don't even have a connection here. So whatever happened on Mars, no happen on Earth. Like they're completely independent. But then at some point you get like interplanetary link, and then like you know what happens. So and this is the question between liveness of safety. Basically, either you wait for as long as needed before you have like this complete information, and you're 100% sure that everyone has the same database as you, or you just like keep going, and if it happens that some people will do, like some people will have different updates, you will just reconcile. So this is liveness, this has safety. So in the first case, you have maximum security, and the second you have maximum responsiveness. So the second trade-off is like open access against like the easier adversary mode. So basically, when you have this network of nodes, it is almost impossible like to control like who joins and who doesn't. If you have a very strict rules just on the level like who can join this network, basically you know that there are only 100 nodes in there. You can basically check all of them, and you have a very easy consensus protocol to do. But if, like in Bitcoin, everyone can join, things get more complicated. And finally, this third trade-off is like simplicity against expressiveness. It's more subtle here, is basically whenever this update goes to the final state, what actually happens with your database, and whether like different updates, how much they will actually, how much they can influence the previous transactions. So for example, in the very strong smart contract situation, it must be the case that all updates that you apply are exactly in the same order as all the guys in the network have. And this puts very strong limitations on how you actually organize your database and how you actually do these things. But on the other hand, if you have more flexible data structures and your more flexible database, you can relax the condition that all the updates have global order, and that everyone has the same order of updates they apply. I will come back to this. So yeah, let me then, do I have more time? I think, yes. So let me like elaborate on this idea of sequential and parallel things. Let's just look closely on how Bitcoin works under the hood. So first of all, the network is open, and whenever someone makes a transaction, this transaction is propagated to all the guys in the network. Then everyone collects all the network, all the incoming request updates, and tries to put them into a block. A block is just like a bunch of transactions in the predefined order. And once someone wins in the lottery based on the some computations called proof of work, this block is distributed back to the whole network. And the beauty of this construction is thus, in order to participate in this lottery and do this proof of work, you don't need to register anywhere. You can do it from any place, anywhere, because whenever you have this incoming block request, you just check that this proof of work satisfies your requirements, and this guy actually was the winner and was the first to come by with this block. And this guarantees that this block has actually is going to be applied to all the local databases on the network. Just because the probability that someone else comes up with the same proof of work within that particular point of time is actually not that big. It may happen like that you have two blocks, but when you stack these blocks together, it is always the case that you have a single chain of blocks and some others are getting orphaned, so to speak. So if you look at your database, or rather the log of the database, it have block 1, then you apply block 2, then you apply block 3, and so on. And since this is a linear structure, everyone has the same ordering of blocks, everyone has the same global order of transactions. And this is a very strong, restrictive, and very safe protocol, but actually it is quite slow, primarily because you first to have redistribute everything to the network and then get back and apply. So in the next session I will talk about Helix mesh, which was actually designed to relax lots of assumptions here, which are very sound if you are dealing with money and you want to have very robust, permissionless, and censorship resistant scheme, but which is actually Bitcoin. But when you deal with data and a more friendly environment, you actually want to optimize throughput and get as little as possible, like the minimal viable thing from this thing, mainly that you have a time stamping in the network. But again, I will come back together after the break.